The James Webb Space Telescope shows once again its remarkable capabilities as it focuses on the deepest mysteries of the universe. It provides us with spectacular images, revealing the structures of the universe in unprecedented detail. Even though these objects are often millions of light-years away from Earth, the high-resolution images from Webb can make them appear as close as the tip of your fingers. However, the most spectacular feature of our video shows that the view of stars can also highlight unusual objects, which may seem strange at first. For example, Webb captured a luminous penguin and a cosmic egg in the vastness of space. But if you ask an astronomer, they'll explain that the image shows the pair of galaxies ARP-142, located about 326 million light-years away. These two galaxies have been engaged in a close dance for quite some time. Located in the constellation Aquila, they have been merging for the last 25 to 75 million years. We know that this will also be the fate of our Milky Way and the Andromeda galaxy in a few billion years. However, unlike the Milky Way and Andromeda, ARP-142 is made up of an elliptical galaxy and an irregular galaxy. These types of galaxies lack symmetry or clear structure, which is evident in this image. What stands out, however, are the impressive tidal arms formed by the irregular galaxy NGC 2936 after its interaction with its partner, NGC 2937. And it's no coincidence that Webb's false color image in the near and mid-infrared shows NGC 2936 as if it were scattering cosmic confetti. These enormous clouds of gas and dust are accompanied by a high rate of star formation that far exceeds that of our Milky Way. While about 6 new stars are born each year in our galaxy, NGC 2936 sees up to 200 new stars forming annually. However, before the irregular penguin can embrace the elliptical egg, which consists mostly of older stars and far less dust and gas, some patience is required. The distance between the two galaxies is currently around 100,000 light-years, roughly the diameter of the Milky Way. It will take several hundred million years before these two structures merge into a new galactic world, a combined view of the pillars of creation. The iconic images of the pillars of creation are not new. The Hubble Space Telescope first captured this massive star-forming structure in 1995. More precise images from other telescopes followed in 2007 and 2011 before Hubble revisited the structure in the Eagle Nebula, about 7,000 light-years away, in 2015. However, none of these images come close to the one Webb presented to the awestruck public in 2022. Our new cosmic eye reveals the pillars in all their facets, showing details that were completely undetectable in the previous images. While newly formed protostars appear as reddish orbs at the tips of the pillars, the curved lines resembling lava are nothing more than the rays that young stars regularly emit onto the surrounding gas clouds. However, the latest combined view of the pillars of creation, published by NASA just a few weeks ago, reminds us that we should not put Hubble's images on pause just yet. Shown in both photography and video, Webb's infrared data reveals the young stars and cold gas, while the Hubble images highlight the hot, bright components of this stellar nursery in visible light. The return of our planetary system. Although Webb is best known for studying the most distant and ancient structures of the universe, we should not forget that occasionally it also takes a quick look at our immediate planetary neighborhood. Webb's fascinating images of Jupiter present our planetary system in a whole new light, showing just how familiar things can look so different literally. The human eye would not be able to perceive the details revealed by Webb. Using 3 different filters, Webb's NIRCam captured the reflected light from the gas giant. This allows the infrared radiation from different wavelengths to be assessed and displayed separately. Since infrared radiation is not visible, the corresponding wavelength ranges are then translated into visible colors. Even the most experienced specialists were deeply impressed by the remarkable level of detail. The images from Webb not only show well-known structures, such as the auroras or the Great Red Spot, but also reveal the delicate ring system that is typically only faintly visible, along with the tiny moons Amalthea and Thebe. Jupiter is the largest planet in our solar system, with a diameter of about 140,000 kilometers. Our Earth would fit more than 1,300 times within it. But if we let our gaze wander 12 light-years away, we encounter the star system Epsilon Indi. Here we find objects that seem even larger and older than Jupiter. The exoplanet Epsilon Indi, B has a mass 6 times that of the largest planet in our solar system. Yet, in the same breath, this extraterrestrial world also represents the coldest and oldest exoplanet ever directly imaged. There are very few direct images of exoplanets to date, most of which show young, hot, yellow gas giants that can be seen in the infrared as relatively bright spots. Of the 25 exoplanets captured directly so far, most are younger than 100 million years, and none are older than 500 million years. The case of superjupiter Epsilon Indi b is quite different. This exoplanet has existed for around 3.5 billion years, and scientists hope to use it to study planetary evolution models and clarify unresolved questions about the later stages of exoplanet development. What remains after the death of a star? Supernova remnants are undoubtedly among the most powerful exhibitions that the universe has to offer. When a massive star reaches the end of its life cycle, it collapses and makes its exit in a violent explosion. What such a stellar death looks like in detail is now shown in a high-resolution image captured by Webb, taken a few months ago in the constellation of Puppis. Specifically, this is a close-up view of the remnants of a cosmic explosion known as Cas, which occurred about 340 years ago. Since these stellar remnants are relatively close to Earth, this structure composed of glowing gas and a central neutron star is one of the most studied cosmic explosions. Although Cas had already been examined by Hubble and the Chandra X-ray Observatory, Webb's NIRCam has for the first time made visible the fibers left behind by the star during its dramatic death in 1680. The inner envelope of the structure, which is made of sulfur, oxygen, neon, and argon, among other elements, appears in bright orange and pale pink. On the outer envelope, there is a white glow that marks the point where the shock wave from the cosmic explosion interacts with the surrounding stellar material. In this regard, scientists suggest that this bright glow is due to synchrotron radiation, the light emitted by charged particles spiraling around magnetic field lines at extremely high speeds. If you look closely, you may spot something resembling a cosmic explosion in the bottom right corner of the image, known as Cas. This is likely a field of radiant dust, captured and heated by the shock wave long after the stellar explosion. Although the image gives the impression that this structure is right next to Cas, it is actually located about 170 nebula has never been so detailed. Numerous sparkling family photographs are also accompanied by an exciting preview of what the James Webb Space Telescope has recently revealed, promoting new details about the indistinct snake located 1,300 light-years away. It has also provided astronomers with an urgent clue about a particular feature of young stars. In a list of references, specialists have identified a group of protostellar jets in this young stellar nursery. Streams of gas emanating from newborn stars interact with the surrounding gas and dust. Normally, these outflows point in different directions. However, in this case, they all point in the same direction, from the upper left to the lower right. This surprising alignment supports the thesis of some researchers who believe that young stars tend to rotate in the same direction when their gaseous birthplace collapses. The reason why specialists have only now detected this particular detail of the Snake Nebula is simple. In previous pictures, the flame-shaped structures appeared as blurry patches or were even completely invisible. Fortunately, the advanced arrangement of the Webb telescope's instruments is capable of penetrating the clouds of cosmic dust and gas, breaking through the optical barriers of older telescopes. Now you can make sure that the times when you haven't clicked subscribe belong to the past. Press the like and subscribe buttons now so you never miss one of our videos. See you next time.